Let me explain homework problem 5. Problem 5 is to prove this famous formula using a binomial theorem. So there are three parts in proving this formula. The first part is to find out the generating function of 0 squared, 1 squared, 2 squared, 3 squared, and squared number sequence. Okay. And this is a quiz problem, and the generating function of this sequence is this function. And this one can be uh, proved using this method. Okay? So using binomial theorem or the differentiation. The second part is once you find out the uh, generating function for the sequence of squared number, the part two is now uh, find out the generating function for the sum of squares. Okay, this much one squared, two squared in general, one squared, two squared up to n squared, and then that is this is a generating function for one squared, two squared, and three squared. By multiplying 1 over 1 minus x, you can get the generating function of this sequence. This is the uh, very important fact, and the part one and part two of homework 5 is a quiz problem, and then the part three is a grace review problem. Okay, of course, in our incoming final examination, this problem will be uh, given in our final examination because this is very important. So I want you to study part one and two and three of this uh, problem. So, okay. Now, no, from this one, from part two, okay, this one, then the the coefficient of x to the n. So this is the coefficient, okay, this coefficient, an, xn, sum. So the find out the general formula for the sum of integers. We need to find out the coefficient of x to the n, that is an. Then we can uh, get the formula. So that's the idea. And let's find out this coefficient in part three. Part three. Then what is the coefficient of f? Now, this is the f of x. And then we want to find out the Taylor series of this one, and find out the coefficient of xn. So this number is the formula. And then first of all, from this one, we can say the numerator is x plus x squared, okay? So this one can be split in two parts like this. Then from homework 4, homework 4, this was a quiz problem. X minus x and 1 minus x to the fourth. This one, and this is from the binomial generalized binomial theorem. This one can be expressed as this is also Taylor series, but also this is the power series uh, driven by the general formula, okay, general binomial theorem. So now in this case, this one n is 4, n is 4, okay, n is 4, and so this is n. In general, this is n minus k plus k minus 1, okay, k. So in this case, n is now 4. So uh, the power series, this one is the constant term is this one. When k is 1, when k is, this is 1, 4 minus 1, or 4 plus 1 minus 1, k, this one, the x to the 1. So when k is 2, k is 2, then let this be 2, 2, 4 plus 6 minus 1, so 5 over 2. 5 choose 2. So in this way, we can get very concrete power series like this. So in general, mm, the the coefficient of this one is given by this one. The coefficient of this one given by this one. Okay. So this is 1 minus x to the fourth 1. Okay. Then then what we want to find out, the f of x is can be split into two parts. X plus 1 minus x fourth x squared. And we want to find out the coefficient of this one of xn. Okay. But already there is x over there. So in this case, the xn minus 1, the product of this one make x to the n. So from this one, we need to find out the coefficient of x to the n minus 1. Okay, x to the n minus 1, that is. So this one is applied to this value. And in this case, now numerator, there comes x squared. And to make x to the n, we need xn minus 2. Okay, so the product of those two makes x to the n. So for this part, we need to find out the coefficient of x to the n minus 2 over there. And then by multiplying this one, we can get the x to the n. So xn minus 2, or this coefficient belong to this part. So this part belong to the red one, and this one, the red one. So for those two, the sum of this one and this one, it can be the answer. Okay. So thus, in conclusion, this one, this plus uh, is the coefficient of f to the x. Okay. Coefficient of xn in f of x. Okay. So f of x is, so again, this one is 1 minus x fourth plus 1 minus fourth x squared. Okay. So the for the power series of this function, and when we want to find out the coefficient of x to the n in f of x, uh, already there is x and there is already x squared. So we need to find out the coefficient of 1 minus x to the 4. This is the, and then we need to find out the coefficient of x to the n minus 1, coefficient of n minus 2. So the sum of those two, okay, sum of those two. Then that is the answer. Then let's calculate those two, and then and in this case, one of the important thing is you see, uh, apple and banana. This value is apple minus banana. Okay, so this is important one. Okay, okay? Because suppose so n choose k is equal to n choose m minus k. This is important because suppose you have well, how many? One, two, three, four, five, seven. Okay. So if you want to select three one, and then so suppose you choose this one and this one and this one, then automatically, so you just pick up those three, then automatically this one and this one and this one are remained. This one remain. So you just pick up and the other four remain. So if you pick up three, then automatically four is also four is remained, and then but for we can think about this one as another pickup. So that's a equal to 7 by 4. That is 7 minus 3. So once you pick up this one, automatically there remains another thing. So there is separate thing, and but the possible numbers are the same. Okay. So from this one is equal to what? 4 plus n minus 3. This is okay. So this is 4 plus n minus 3 minus n minus 2. Okay. And for this one, 4 plus n minus 3 minus n plus 2. So this one and this one is cancelled out. And then 4 minus 3 is just 1. So, okay, this one. So this value is very simplified as this one. By the same reason, this value can be simplified as this. Now we can compute this value. Then what is this? This one is, the first one is, so the beginning number is 4 plus n minus 3, okay? And the next one, the subtract one, then 4 plus n minus 4, and subtract one more, 4 plus n minus 5. So in the numerator, there the three uh, values appeared on the numerator, and the denominator is now this is k, and this is 3 factorial. So in fact, this is k factorial, and the above one is k many decreasing value. Okay, from this one, let's see what is this. So this is 4 minus, this is n plus 1. And what is this? This is just n. And what is this? This is, what? Let's see, this is n minus 1. Okay. Okay. So this value is 3 is 6 factorial. So just 6. So this value, from this value we have the denominator is 6 and n, okay, n plus 1, and also n minus. From this one, let's see, this one is, the numerator is 4 plus n minus 2, subtract 1, then 4 plus n minus 3, subtract 1 more, 4 plus n minus 4. And so there are three. This is k. Okay, three values appeared in the numerators and denominator 3 factorial. And this one is n plus 2. And this one is what it is. It's n plus 1. Okay. And what it is, this is just n. Okay. So this one plus 6. N, okay, n plus 1, or n plus 2. And then look at this. Those values are common. Okay, common. So this one is 6, n. N plus 1 is a common value. And the next one is what? N minus 1 plus, what's next? This is n plus 2. Okay. So then, what is it? This one, there are 2n. So this is 2n, and this is plus 1. Okay. So finally, the sum of those two is n plus 1, 2n plus 1, divided by 6. So we have the answer. So that is finally, we proved that uh, the sum of integer squares, the formula is like this. So this is very beautiful proof, okay? So using uh, generating function, we can find out this beautiful formula. Okay. So a detailed explanation can be seen at this place. Similarly, you can get this result. This is the part 3 of homework 5. Okay, then, so we can finish the review for the coming quiz and grace test problem. So let's go to our final topics in our discrete mathematics. So we have no enough time to cover graph theory. But in discrete mathematics, as I told you, the combinatorics. So combinatorics is find out the possible number of ways. Okay, and graph theory. There are graph theory. Two main topics in discrete math, combinatorics and graph theory. In combinatorics, uh, the modern way of counting something, the generating function is a very helpful method, as you see from example. Okay? And graph theory, and in this case, matrix, we can represent matrix in terms of matrix. And so for the first part, combinatorics, generating function is a very important concept. And for graph theory, matrix, matrix is a very powerful tool to study graph theory. Okay, the graph theory is important in a kind of computer algorithm. So because using the graph theory, you can search a very shortest path and very uh, you can search something and sorting and searching and finding various paths. So graph is a kind of playground for computer algorithm. Okay. So combinatorics is also playground for a lot of computer coding algorithm. Okay. So those two topics are important. Then let's find out the graph theory, just introduction, the graph theory. Graph theory is just a graph is look like this. So suppose you have a city, so you have a city, and if there is a road between the city, then you can draw this kind of uh, connection representation. Okay, so this this one called the vertex. Vertex. and between the vertex, if there is a line between the vertex, then this one is called edge. Okay, edge. And this one is called the vertex. But uh, in computer science, especially in computer science, uh, some people uh, use a node, NODE, instead of vertex. And edge is used. So nine nodes, there is a vertex and eight edges like this. But to represent this graph and to calculate something, we need to find out mathematical representation. And the mathematical representation is a matrix. But uh, for the computer programming language, sometimes a dictionary representation is also uh, used in manipulating this graph. So for the graph representation, matrix and dictionaries are uh, two main uh, representation methods. So what is the matrix representation? Suppose this is the vertex. So usually in computer science, the starting number is 0, 1, 2, 3. So this is a very simple uh, connection like this. Then how can you represent this one in terms of matrix? Then uh, there are four vertex. So four vertex. Then you have four rows and four columns like this. Four rows and four columns, and then oh, sorry, this is 0. Now there is a connection between 0 and 1. Then because so from 0, 1, and if there is a edge between not 0 and not 1, then this one is this is true. Okay, there is an edge like this. And how about 0 and 2? 0 and 2, there is no direct edge. So there is no edge. So no edge means 0. So usually in computer science, 1 is true and 0 is no, false. And then how about 1 and 2? 1 and 2, and there is an edge. So this is 1 and 2, there is 1 over there, okay? Then how about 2 and 1? So 1 is connected to 2, but also 2 is connected to 1. So 2, 1. 2, 1, there is also 1, okay? In this case, 1 is connected to 1, 0. So this is 1 and 0. There is 1. In this way, just comparing uh, row vertex and column vertex, if there is a connection, then just write down 1. If not, write down 0. In this way, we can make a kind of matrix representation for the graph. This kind of matrix is called adjacency matrix. Okay, adjacency matrix. This is graph. So sometimes in many cases, adjacency matrix is represented by letter A, and graph, this kind of graph, capital letters G. Okay, so this Aij means if node I, vertex I is connected to vertex J, then there is 1. If this is 0, if there is no edge between vertex I and J. But sometimes there is in this case, this there is a arc. This is one way. So there is a way from W to Y, but there is no because this is one way. There is no connection between connection from Y to W. So only WY there is one over there. Okay, one is there. But how about Y from Y to W? Y to W, there is nothing because this is just one way. And this kind of graph is called directed graph. Okay, direct. But usually, uh, in most case, there is a two-way system. So uh, this is this is not popular in graph theory, but sometimes this is useful to represent a very special case. So suppose you have this kind of graph, and since this is this kind of graph is called tree, but anyway, then we can represent this one using uh, metrics and but also a dictionary, Python dictionary. Okay. So for example, let me explain this graph using. Okay, let's go to the next part. Let's go to directly go to our homework problem. So this homework problem will be in our final examination homework because this is a very introductory concept, but also basic for graph theory learning. So memorize the following code, dictionary representation and adjacency matrix representation. So suppose we have this kind of graph. How can you represent this one in terms of uh, dictionary and metrics? So suppose from here, so there is a zero over there, like this. And then, first of all, dictionary representation is dictionary, let use uh, letter G to represent this graph. The dictionary, then, okay, vertex zero, for the vertex zero, vertex one and vertex two is connected because from this vertex, the vertex one and vertex two, there is connection, okay? This is the dictionary representation. How about from vertex one, okay? This is the key and this is the value. From the vertex 1, vertex 3, and vertex 4, and vertex 0, there is a connection. So this is vertex 0, and vertex uh, 3, and vertex 4 is connected. Okay. So in this way, you can see this one. How about 6? From vertex 6, the vertex 4 is relay connected. So in this case, vertex. So it's a starting set value, set notation. This is ending notation. So this kind of representation is called the dictionary representation for this graph. But then how about the matrix representation? So from the matrix representation is now there are how many vertex? So the starting one is zero. So there is seven vertex. 0, 1, 2, 3, 4, 5, 6, like this. And also there are 7 columns. 0, 1, 2, 3, 4, 5, 6. Then how to give a numbers? So like this. Then, for example, look at 1, 3. So this is 1. How about the 3? 0, 1, 2, 3. Okay. like this. So this is the from vertex 1, from vertex 3, there is an edge. So there you can write down 1 over there. Then how about vertex 3 and vertex 1? So from this point of view, vertex 3 is connected vertex 1. So from vertex 3, and then this value is 1. This value means from vertex 3 to vertex 1. There is a connection like this. So in this way, you can get this kind of matrix. Okay. So whenever you have a graph, then the Python dictionary, Java dictionary, and dictionary representation can be used, but also matrix representation can be used. Okay. Then how to find out? So if you are given by this kind of matrix dictionary representation, how can you convert this one into matrix representation? That is our first problem. Okay. So by clicking this one, so this is the dictionary representation. Then what do we have? We have, okay, this is a matrix representation. So this one is from graph dictionary to adjacency matrix. This is the first code you must memorize. Then what's the next code? Next code is, suppose you have adjacency matrix like this, the adjacency matrix. How can you get the corresponding dictionary representation? So let's click this one. Then what do you have? From here, final result is this one. Okay. So this is a dictionary representation. This is a dictionary representation. Okay. So there is the two-way connection between a matrix and dictionary. So the homework 6, the last one, is to study the code, okay, connecting on dictionary representation and matrix representation. So even though this is a simple one, but this one is a important code because for this kind of thing, this is the four, there are another four and another four, and then like this. So there are three, four is four command appears like this. So uh, there is a somewhat uh, multiple repetition arise, and also there is another important thing. Anyway, dictionary and metrics are very important in studying uh, graph theory. Okay, let's stop here because I will explain this one more. Anyway, but this problem will appear in our final examination. So uh, I will, in the last class, I will explain this code again so that you can prepare the final examination. Okay, then in this video, I just explain homework 5. Homework 5 is the formula for the sum of uh, squared numbers, and number 1 and number 2 are quiz problem, and number 3, part 3 is a grace review test problem, and also problem the final homework problem is homework 6. Homework 6 is related to graph theory representation, the dictionary representation, and adjacency matrix representation. And this will be in our final examination. Okay, so I want you to study those homework 5 and homework 6 together. Okay, thank you very much for your attention.